Hello! Welcome to Periodic Trends. So today we're going to be talking about what a periodic trend is, why it's important, and how we can apply it. Getting started. So our lesson objectives are trying to predict the trends of atomic radius, electronegativity, atomic number, and ionization energy. So, how is the periodic table organized? If you were to look at the periodic table, what would you see? What are the colors, what are the elements, the sizes, the shapes? In this periodic table, we see that the different groups of elements have different colors. We see that there's labels at the tops and bottoms and sides. We see that they have different properties, and so we are going to define some of these properties. Metals. Metals make up the majority of the periodic table that you see. Metals only engage in ionic bonding, which will be important later when we're talking about the trends of the tables. Nonmetals. Nonmetals are typically liquids or gases. These only interact in covalent bonds. These are things like helium or air. That would be a nonmetal. So, what are these trends? Today we're going to look at electronegativity, atomic radius, atomic number, and ionization energy. All these are important periodic trends in order for the rest of chemistry to make sense. First up is atomic radius. Atomic radius is how big the atom is. The bigger the atom, the more electrons it has, the more protons and neutrons it has. The bigger the radius, the easier it is for it to bond to other atoms around it. Atomic number, this one's probably one of the easiest trends. It increases going left to right and increases going down. This tells you how many protons are in the nucleus and is labeled just going 1, 2, 3, 4, 5, 6, 7. The higher the number, the more protons it has. Electronegativity. Electronegativity is how much an atom wants to get electrons. So for instance, lithium doesn't want electrons very much, and while on the other side, fluorine wants to grab as many electrons as possible. Ionization energy. This is defined as the amount of force it takes to remove an electron. So for instance, from fluorine, it loves its electrons, it's not going to let it go. Francium, on the other hand, on the other side of the table, will let go of its electrons very easily and give it to anybody who wants one. Experimenting in periodic trends will happen throughout the semester. You are going to look at different elements and how they interact with each other. These periodic trends will be shown all throughout these different experiments. So why are these important? These elements all interact very differently, and all the periodic trends have their purpose. So when you're combining atoms, when you're putting things into solution, when you're basically doing any chemistry, you will be using one or more of these trends in order to predict what will happen. When applying these periodic trends, you are never actually just applying one at a time typically. Typically, when you're looking at periodic trends, you are going to look at multiple of them and to figure out what your end result will be. So now you're going to think about what are some ways that you can use periodic trends, how can we predict outcomes using periodic trends, and think about examples of the highest and the lowest, the biggest atom, the smallest atom, the most electronegative, the less electronegative, and think about why that is.